Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engaged New York Math, Module 5, Lesson 17, going from nets to surface area. We've talked about area in the past. You've had shapes, whether it was triangles, rectangles, squares, and you found the area, meaning the area that you could kind of fill in. If you think about it as a wall, you might paint that area, right? The inside, so to speak, the flat surface. Now, when we talk about surface area, we're talking about a three-dimensional figure and finding the area of every possible side, including the back side, the underside, the left, the right side, the top, the front, the back, whatever, RDOS track, right? But finding the area of every side and combining it to see what the area of the entire shape is across its entire surface. So, let's take a look. Now, this is a little hard to see, but we've got this shape here. It looks like a T, right? If we were to say that each of these squares is a 1 centimeter by 1 centimeter square, then across the top here we would have 2 centimeters. Here we'd have 1 centimeter. Again, here we'd be looking at 2 centimeters, 1 centimeter, 2 centimeters, over here we have another 1 centimeter, inside here we have 2 centimeters, here we have 1 centimeter. Now you'll notice that they have, the reason I hope you could see, I should have mentioned it, they've broken it up into these different shapes, right? Looks like that, okay? So we're going to start to find the area of the different shapes. Here we would have 2 times 1 would give us 2. Here we have 2 times 1 would give us 2. Here we have 2 times 2 give us 4. Here we have 1 times 2, which would give us 2. Here we have another 2 times 2, which would give us 4. And here we have 2 times 1, which would give us 2. If we're looking at length times width. Now, that's the area of each individual piece. Now we have to connect them all together, add them together. 2 plus 2 is 4, plus 2 is 6, plus 4 is 10, plus 2 is 12, plus 4 gives us 16 centimeters squared for our the surface area of the entire shape, the entire net. Now, let's look at another example. This one's a little different. This one is obviously clearly a square pyramid, right? Because you have a square base, and then each of these would come together at a point, and so you'd have a pyramid. We have 5 faces, the base, and then each of these triangles, right? So we have 5 sections there. We need to find the area. Base is pretty simple, right? 1, 2, 3 by 1, 2, 3. 3 times 3 is going to give us 9 centimeters for the surface area of that inside square. Now for each of the triangles, we're going to say that first of all, we need the height, right? So that goes, oops, sorry, I messed up. That goes straight up. So that's 1, 2 cubes, or 2 squares, right? So our height is 2, and if we're looking at 1/2 base times height for a triangle, we're going to end up with 1/2. The height is 2, right? Because it covers that one square and this one square to get to the top. And then our base is 1, 2, 3. So we have 1/2 times 3 times 2. So 1/2 times 3 is 1.5, times 2 is 3, so we have 3. So this internal square, we have 9 centimeters. For each triangle, we have 3. So we end up with 9 plus 3, plus 3, plus 3, plus 3, because there's 4 triangles. So 9 plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 3 is 21. We end up with 21 centimeters squared is the surface area of this entire shape. Okay, we're going to go ahead and stop there. We'll do some more examples in class and look at some different shapes. Key thing is, obviously use 1/2 base times height. Looking at that rectangle, it's length times width. They're using the same formulas you've used before for area, except this time we're just taking these different pieces, finding the individual area for each one, and then adding them all together in the end. That's how we find surface area. We'll do some more examples, and you'll be able to kind of piece and pick that together, put that together. All right, thank you for watching. We'll talk to you soon.